As developers, it's easy to let our focus be primarily on creating the objects that we need and making sure that they begin their existence the right way or set up the way that they should be. And we'll do this with our alloc and init calls. But again, we have to be very conscious of making sure that our objects reach the end of their lives the right way so that we can be disciplined and control what happens at the end of an object's lifespan just before it's deleted. Once again, if we were to look at the idea of memory allocation, if we use the alloc and init calls to create a new pointer called Fido that points to an object in memory, it has a retain count of 1 automatically. This is the way that Cocoa is going to work for us. We can then use that object, call methods of it, access its instance variables, do whatever we want with that object, but at some point we need to say release. We're calling the release method on that object. Now you may be wondering, where did this method come from? In fact, where did the alloc method come from? If we're calling alloc and init and release, where did those all come from? Well, it's actually because we're always inheriting. When we define a class, we're always inheriting from NSObject, unless we're inheriting from something else, which itself inherits from NSObject. And NSObject has alloc and init and release all defined inside it, so we'll always have those methods. Now what's going to happen at this point is that when we call release, we're not explicitly destroying the object, but we're letting Cocoa know that we're done with it. We don't destroy it, but we're telling it we don't need it anymore. It's got a retain count of 0, and then at some indeterminate point in the future, and it's probably just going to be a few milliseconds later, that object will be taken care of and destroyed. But sometimes we need to be a bit more explicit about exactly what's happening at the end of its life. So here I've got some sample code up. This is just creating an object using a couple of its methods, and then we're just doing that all within the main method. Now, because we're doing this all inside the main method, when we actually get to the end of line 10 and main method returns, our object is going to end up being destroyed anyway. But it's good practice to get used to the idea that if we're using the alloc and init method to create the object, which is what we're doing on line 6, we should be calling release ourselves. You want to get into that disciplined approach, that all your claims of ownership are being matched by a release. So I'm going to release this object just before the return. I use the object name and say release. And notice how it even detects that it's there. And that's because the release is defined as part of NSObject, which we are inheriting from. How do I know we're inheriting from it? Well, if I jump to the definition of the dog class to my header method, I can see that on line 3, it says @interface dog : NSObject. That means the dog class inherits from NSObject. We get things like init and alloc, and we get even a few others that we're going to use. So that's why we have those methods available. But the question is, what actually happens back in our main method when we call release? We're telling Cocoa that we're done with it, and it will take care of deleting the memory that this object is using. However, there's one more thing we could do if I wanted to be specific about what happens at the end of this object's lifetime. I can write another method. I'm going to jump into my implementation file for this class, where I have a method written here called dalloc. It lasts from line 13 to line 16. It's a method that's defined as dalloc, all lowercase, and it returns void. Now, we might wonder, where did this come from? Because if I look in my header file, I did not say that I would have a method called dalloc. I just said I had bark and setName. But in my implementation, I have the bark method, I have the setName method, and I have dalloc. Well, I don't have to put dalloc in my header file because dalloc is in the header file of NSObject, and because we're inheriting from it, we already have that. Dalloc is a method that you can write if you want to control or add some code that will get called just before your individual objects are deleted. In this case, I've got a call to nslog saying I'm about to be destroyed, and we'll be able to check and see if that actually works. And because dalloc is defined in NSObject and it's taken care of its own cleanup, then line 15, first time we've seen this, we're calling super dalloc. What this actually means is, yes, we're replacing the dalloc call of NSObject with our own more specialized deallocation call, but we want to make sure that the one in NSObject that takes care of all sorts of other stuff still happens. So by default, this is what we do when we write our own dalloc method, is the last line says, super dalloc, go and do what you would have done in your superclass otherwise. Now, You do not always need a dealloc method. Don't make the mistake of thinking that because you've got a release, you must have dealloc. We're going to be calling the release calls all over the place. Dealloc only needs to exist if you need to do something special at the end of life of your objects. So let's jump into our main method just to look what happens here. Line 6, we create a new instance of the dog class. Line 7, we set its name. Line 8, we call the bark method that should output a message to the console. Line 10, we call release. That should cause the dealloc method to be called. Now note that we don't call it directly. You never call dealloc directly on your own objects. The only time you'll ever write the line dealloc is when you say super dealloc at the end of your own dealloc method. But it should happen. Let's check this out. I'm going to click build and check that our program builds. Build succeeded, and I click build and run. Again, it's a console application, so I need to access the console from the run menu. And I can see my two messages there. One is the bark method that says Woof said Fido, and then automatically the dealloc method was called when we released this object, and it destroyed that object. So dealloc calls aren't always necessary, but when they are, they're essential. This is if you create an object that's holding on to other resources. It's, say, holding on to open files, that kind of thing. It's all part of the idea of cleaning up your own objects.